In Chapter 3, you'll study some of the most commonly used descriptive measures in statistics. In 3.1, you reviewed mean, median, and mode, all of your measures of center, which can give a lot of useful information. But certain sets of data can have a mean and even a median that are exactly the same, but yet the sets of data themselves can be very different. This is where measures of variation can become very important. And measures of variation basically measure the spread of the data. And the one we're going to look at right now is called the standard deviation. And the standard deviation basically indicates how far on average the observations are from the mean. If you notice on your formula sheet, and as we go through any of these problems throughout the course or you're doing anything, you should always have that formula sheet in front of you. You will find it in Web Study under your timeline. Please make sure you have it out as we're going through the problems. When you look at standard deviation, you'll see a lot of different formulas. The ones with the S's, the two that I have here, are for sample data. And you'll see some other ones that use a sigma. And if you look carefully, the only difference between the ones that use the sigma and the one that use the S is what you're dividing by. When we're using a sample, as we are here, we divide by n-1, n representing the size of the population. The size of the sample, sorry. But when you're using sigma and you're using the entire set of population data, you can just divide by the number that are in the population. With sample, you need to look, we find that you give a better estimate of the population when you divide by n-1. So let's go through each of these formulas and make sure we understand the symbols and how to use them. So I have 5 pieces of data here. These are a sample of 5 student ages. The ages are 15, 18, 21, 28, and 33. And first we're going to calculate the standard deviation using this formula here, which is called the defining formula. And the other formula is called the computing formula. Personally, I always find the defining formula fairly easy to use, and I always use that one, but you may find the computing one easy, both of which are on your formula sheet. Either one can be used on the test. You just need to make sure you show all your work. So as I go through a sample here, I'm also showing you a sample of the work I expect to see when you take the test. So now, notice on both of these, we need X bar. X bar, of course, is our mean. To find X bar, all you need to do is to sum all your Xi's, which are given. Xi, of course, represents each individual piece of data, and divide by, in this case, 5. If you go ahead and do that, you will find that your mean comes to 23. So now what I'm going to do is set up a little table. To use the defining formula, I'm going to list all my Xi's. They do not need to be in chronological order, but in this case it just makes it a little bit easier. Now, look at this formula carefully. What is the first thing you think you need to do? Just like any order of operations, you always want to look inside the parenthesis first. Notice we are taking Xi minus X bar. So that simply means for each piece of data, I am going to subtract the mean. So I have 15 minus 23, and then after I subtract it, I can square it. Squared. Calculate each one. That one's going to give me 64. And then, of course, 18 minus 23 squared is 25. 21 minus 23 squared, that's 2 squared, so that's 4. 28 minus 23 squared, that's 5 squared, 25. And 33 minus 23 squared, of course it's 10 squared, which is 100. Now, notice after you take each xi minus x bar squared, then you need to take the summation. So all you need to do at that point, let me move my paper up a little bit, is take the summation of this column of numbers, which comes out to, I believe, 218. When you review the formula, after you take the summation, you divide by n minus 1, and then take the square root. So, to find s, I would need to take 218 divided by 5 minus 1, square root of that. So my standard deviation, 218, by the way, divided by 4 comes out to 54.5, and the square root of 54.5 comes out to approximately 7.39, and I'm going to make that 7.4. A simple rule of thumb when working with statistics is you always round one decimal place further than your original set of data. Since our original set of data was whole numbers, I'm going to round to the tenths. So we get 7.4. Now, just to prove to you that these formulas are exactly the same and should yield the exact same answer, we're going to go ahead and calculate it using the computing formula. So now look very carefully. There's a big difference between this summation of your xi squares and this summation of your xi squares. That parenthesis basically helps provide the order of the operation you need to make. So the first thing I need to do is figure out the sum of xi squared without the parenthesis. All that means is I'm going to take each of my xi's, square them, and then add them up. So I have 15 squared plus 18 squared plus 21 squared plus 28 squared plus 33 squared. And if you do the math on that, you will see that you get 2,863. Now the next one is a parenthesis of summation of xi, and notice the square is outside the parenthesis. That tells me I'm going to sum my xi's first. 15 plus 18 plus 21 plus 28 plus 33, and then at the end take the square root. So this is going to give me 115 squared divided by n, which comes out to 13,225 divided by 5, which equals 2,645. 2,645. So to calculate the standard deviation here, I have the summation of xi squares, 2,863, minus the summation of the xi's, that squared divided by n, which was my 2,645. I'm going to divide by n minus 1, and then take the square root, which again is going to give me 218 over 4, square root of that, which comes out to, of course, the square root of 54.5, or approximately 7.4. So, numbers come out exactly the same. It doesn't matter if you use the computing or the defining formula, but on all tests, I must see the work. Because if your numbers are too far off, suppose for an example you got 6.9 or 7.8, I can't see what type of mistake you made in order to award you partial credit.